Everything we write in Shplait conforms to the shrubbery grammar. For example, the Shplait function, which takes x and y and does some things, it conforms to the grammar because it is a group starting with one term, fun, that matches the symbol case, and then another term that is a parenthesized one, matching this parenthesis case, where inside the parentheses there are groups separated by comma. So x and y are each separate groups here, and then we have a block term which has groups inside each separated by semicolons. We normally write new lines instead of semicolons, and so on. When we write quote marks in Shplait, this still conforms to the grammar because quotes is one of the term forms here where we have groups separated by semicolons or new lines. There's some extra constraint not shown in the grammar, which is that blocks and alternatives needs to be at the end of a group because they don't have closers on them. In any case, what Shplait does with its quote form is give you this abstract syntax of shrubbery directly. It gives it to you in the form of a syntax object, and we normally think of a syntax object as a thing that we just use with pattern matching or with templates, but there is this abstract syntax sitting behind that, so there must be some representation, some term type internally that has a variant for each of these kinds of terms. That term type is not exposed directly, but we do get predicate functions that recognize the different variants of term. We've used syntax as integer, syntax as string. There are a bunch more, like syntax as parens, syntax as list, and so on. So these functions can be used to recognize different cases of terms. And what if we want to pull a term apart, like we want to get at the groups inside here? Well, there's also a collection of functions that convert each variant to something with the pieces inside. So we can get the integer out, or we can get a list of groups using syntax to list. We can take a group list and get individual terms by using syntax group to list, and so on. And of course, there are functions that go the other way. If we have an integer, we can turn it into a syntax object, an instance of this variant. If we have a list of things, we can turn it into a syntax with square brackets, and so on, using these constructor functions. So we could use these functions instead of pattern matching to implement our mo parser, for example. We have been using syntax as an integer, syntax as symbol. We could write more functions that work like that. We can write our own syntax starts function that takes a syntax object, pulls out the list of terms from the group, and sees if the first term is let here. And then we could look for an equal sign inside that, and look for equal sign and get the pieces after it, and so on. And you see, we can write this parser without any pattern matching. We need to write our own little helper functions like syntax starts, which takes this group syntax object, turns it into a list, and checks whether the first thing is a term, and so on. And if we do that fully, it ends up looking like this. So we have a parse here with no match forms, just our helper syntax starts, syntax contains, and so on. So this is a harder way to write the parser, but it means we remove the mystery of pattern matching and template construction. All we have to do is write our helper functions that use these predicates and selectors. So we're going to build on these pieces to implement pattern matching and templates for mo. We can change our parse back to just use pattern matching, but at the mo level, we're going to implement pattern matching ourselves.